In the previous video, we analyzed the in the behavior of a polynomial function with even degree. Now, let us see in the behavior of a polynomial function for the case where degree is odd degree. Now again, I will give you a template to analyze this one because most of you knows these functions. Let's see this one, and the other one is this one. These are my templates, because if you understand these graphs, then it will be easier for you to analyze the in the behavior of the highest degree with odd degree. Negative infinity, this is negative infinity to positive infinity. So this graph is f of x is equal to x cubed, remember? And this graph is f of x is equal to negative x cubed. Now look at the degree of this one is 3, which is odd, remember? And leading term is positive coefficient, whereas this one is the degree is 3 and leading term is negative x cubed. Look at attention to the negative part. Now the in the behavior, now for the first one, as x goes to positive infinity, f of x goes to positive infinity. As x goes to negative infinity, f of x goes down, negative infinity. Look at. So this one up, when x goes positive infinity, goes down, x goes to negative infinity. The second one with a negative coefficient, as x goes to positive infinity, f of x goes down, right? Negative infinity. As x goes to negative infinity, then f of x goes up. Now you can look at the graph. So x goes positive infinity, then the graph goes down, right? When x goes negative infinity, this goes up. So these are the template to analyze any higher degree of odd degree polynomial based on this graph. Now let us see example. Given f of x is equal to, let's say, to 34 x to 77 plus x to 20 plus 20 x squared minus 100. Now it seems that this is a very complicated polynomial with degree 77, but you can state the end behavior. The end behavior of the polynomial. Now, in order to state this, look at now, this is the leading term is this one, right? Now just go to the first template, which is x cubed, which is odd. This is compared with, f of x 34 x to 77, because it is a positive coefficient and it's odd degree. Now it has the same behavior, right? So this one, the end behavior, as x goes to positive infinity, f of x goes to positive infinity. As x goes to negative infinity, f of x goes to negative infinity for this degree 77, because the degree is odd. And the graph looks like, for example, the graph of this one, if you go to positive infinity and negative infinity, to this side this graph is up, this side the graph goes down. So the interpretation based on the templates of f of x is equal to x cubed. And let's see another example with example given f of x is equal to minus 35 x to 17 plus x to the 6 minus 10 x squared minus 2. So this is some random polynomial, but you are asked to state the end behavior of this polynomial, the end behavior of this polynomial, the end behavior of f of x, or this given. Now what you should do, you have to compare this one with f of x is equal to minus x cubed. Remember, compared with the leading term of negative 35 x to the 70. So they have the same property, right? Now you can draw the graph, look at that one, and what is the behavior of that one. So if you look at, you can just draw a simple graph of this one. Yeah, this. So the behavior is similar. So as x goes to positive infinity, f of x of this degree 17 goes to negative infinity. As x goes to negative infinity, f of x goes to positive infinity. So those templates are important. So generally the graph of this degree 17 with a negative coefficient looks like, on the when x goes to infinity it goes down, and when x goes to negative infinity goes up. So now if I give you any polynomial of even or odd degree with positive and negative coefficient, you can use those templates to analyze or state the end behavior of the polynomial. I'll come to the next video with examples.